Welcome to Georgia Highlands College Math 97 and Math 99 video tutorials. In this video segment, we'll be answering the question, how do you add rational expressions with unlike denominators? So this is definitely a process, but the first step in it is to find the LCD. And if you're not sure what that means or how to do it, we have a previous video instructing you just on how to do that one step. After you've found the LCD, you're going to write equivalent expressions with the LCD as the denominator. And we also have a video telling you how to do that step as well, but I'll show you in the example we'll look at in a moment. After you have equivalent expressions, you're going to add the numerators over the LCD and combine like terms in the numerator, factor and simplify if possible. But let's go ahead and take a look at an example to clear this up for you. All right, so we have the example 2 over x plus 3 plus 4 over x minus 3. And the first thing that I'll point out to you is that x plus 3 is a factor itself and x minus 3 is a factor. So we don't have common denominators here. And as instructed in our last video, the way to find common denominators is to list the factors of each of the denominators. So for my first denominator, it's only got one factor besides 1, and that is a factor of x plus 3. And for my second one, I have a factor of x minus 3. So the process is to list all the factors that show up in any of the denominators. So my LCD for this particular problem is going to be x plus 3 and x minus 3 times x minus 3. So that is what we're shooting for in the denominators of both of these expressions here. All right, so we want to find equivalent expressions with the LCD as the denominator, and we do that by multiplying by 1 in that clever form. And the form that we're looking for is whatever factor we need to multiply by to create the LCD. So for this first expression, we already have a factor of x plus 3, so we need a factor of x minus 3. So we multiply by 1 in the form of x minus 3 over x minus 3. So that's a really crazy looking way of writing the number 1, but anything divided by itself is 1. So you're not changing that first expression, you're just going to make it look a little bit different. And we're going to add that to our next expression, also multiplied by 1. However, you're going to multiply this one by whatever factor it's missing, x plus 3 over x plus 3. So I'm just setting up here in that step to get that common denominator, the least common denominator, by multiplying by 1 in our clever form. So we have a lot of distribution to do. This 2 needs to be multiplied by both the x and the negative 3, and the 4 needs to multiply by the x and the positive 3 for that expression. So looking at that first term there, we go ahead and distribute the 2, and we get 2x minus 6 over our now common denominator. Remember, you just multiply fractions straight across, so our denominator is x minus 3 times x plus 3. And that will be added to, okay, 4 times x is 4x, 4 times 3 is positive 12, so that'll be added to 4x plus 12 over x minus 3 times x plus 3. Hopefully you notice we now have common denominators. So we simply combine the numerators over the common denominators. 2x minus 6 plus 4x plus 12 over our common denominator, x minus 3 times x plus 3. Combine any like terms in the numerator. So I see like terms with my x's here. And I have like terms with my constants. So I just want to put all that together. 2x and 4x gives 6x. And negative 6 and positive 12 is positive 6 over x minus 3 times x plus 3. You should always do at least a spot check to see if you need to factor and divide any common factors out. Now the numerator will factor, it's got a common factor of 6, but when I divide that 6 out of both terms, I'm left with x plus 1, which is not a common factor with either of the factors in the denominator. So I can just leave the answer as it is here. And that is my final expression for adding those two rational expressions. I hope that this has been helpful and sort of cleared any muddiness up about how to add rational expressions with unlike denominators. We'll be doing another video on the same topic that has a little more complex of an example in it, just so you feel like you have your feet under you before you start doing this on your own. If you have any other questions about adding or subtracting rational expressions with unlike denominators, make sure to contact your Highlands instructor. Thank you.